Okay, hey everyone, this is Connor Mead with the Calculation Center here again with our second video on solving systems of linear equations. I'm going to assume you've seen the first one already, where we kind of went through the basics of solving a system of linear equations, like the row operations and things like that. And this one's just going to assume you know that and go on to the next kind of case we have to deal with. In the first video, we talked about solving systems of linear equations with a single solution. That was the system of equations we were dealing with. In this one, we're going to look at a system of equations that has no solutions and look what it looks like and how we can identify that and things like that. So we're talking about this system of equation up here, and we're going to assume we already know how to convert it into augmented matrix equation. Okay, and just as a quick reminder, you just write down the coefficients of each of your variables and the constants that are equal to on the right hand side here. Okay, so this would be read as x plus 3y plus z is equal to 3. And notice down here we have a 0 because z doesn't appear in the third equation, right? We have 0 z's in the third equation. But from here we're just going to proceed on as usual. We've put our pivot already around our top left entry, and we're going to use the pivot to turn everything below it into 0. So that means row 2 is going to become row 2 minus 2 row 1, and row 3 becomes row 3 plus row 1. Okay, that will be turned the entries below our pivot into 0. So we get 1, 0, 0. Just going to pivot around this. The first row won't change again. And now we just need to keep track of what changes. So row 2, we're subtracting off 2 copies of row 1. So this is 8 minus 2 times 3 is 2. And 4 minus 2 times 1 is 2 as well. 6 minus 2 times 3 is 0. And then let's look down here. We are adding row 1 to row 3. So we get minus 1 plus 1 is 0 indeed. Minus 2 plus 3 is 1, and 1 plus 0 is 1. And 3 plus 4 is 7. Okay? Now we put our pivot around this block here. And what we're going to do is, I guess we're going to subtract off we're going to send row 3. So row 3 minus a half row 2. Okay? So we're multiplying row 2 by half to make it 0, 1, 1, 0. And we're going to subtract it off of 0, 1, 1, 7. And what we're going to end up with is 1, 3, 1, 3, 0, 2, 2, 0. Notice that I could replace this with 0, 1, 1, 0 if I wanted to. But this is going to become 0, 0, 0, 7. Okay? And now you might see what's going wrong. So this second pivot of ours, we've turned everything below it into a 2. But now we can't put our pivot in the last box. We'd like to put a pivot around here, but you're not allowed to put a pivot around a 0. Okay? So this is basically how you identify that you've got a system with no solutions. You end up with a pivot to the right of the line here, this line of constants. Or equivalently, you have a row of zeros equal to a constant, right? Because this equation here, this third row, can basically be read as 0x plus 0y plus 0z is equal to 7. And it's obviously no values of x, y, z is equal to 7. I'll just make a little note there. This is actually saying this third equation. So this first equation here, remember we can always kind of turn it back to this. It becomes x plus 3y plus z is equal to 3. The second row is kind of like 2y plus 2z is equal to 0. And this last one says 0x plus 0y plus 0z is equal to 7. But this thing here is equal to 0 for all x, y, and z, so therefore there can't be any solutions to our system of linear equations. Okay? This is Connor Mead with the Calculation Center. We'll see you in the next video.